Hey guys, this is Grayson with Phoenix LiDAR. Today I will be discussing a little bit about our cloud viewer. It's called the Phoenix Cloud Viewer, and it allows you to view your point clouds via LiDAR mill via your web browser. So right now what we're looking at is a LiDAR mill point cloud generated, and we're viewing it in Chrome. Poetry does support Chrome as well as Firefox, as well as Safari and a couple others. But I must preface that the web browser that you do use, make sure that if you have a decent graphics card with your notebook or your desktop, make sure that the web browser uses that graphics card and not the standard notebook graphics card. So anyway, we'll discuss a little bit about Cloud Viewer and a lot of the features that are with it, and some tips and tricks that I use to analyze point clouds. So when you open the point cloud, sometimes you will notice that some of the flight lines will not load. Now, when we do load the point cloud, you'll see multiple flight lines appear and open, and many times you'll notice a couple flight lines will not appear. Just refresh your web browser, press the reload button, and you will see those flight lines appear in the point cloud. Just a general overview. We have our trajectory on top. So this red line here is your trajectory. You may see two trajectories. One is your standard trajectory, and the next is the LiDAR snapped trajectory. And below you see the point cloud. In default view right now is elevation mode. Up at the top here, you have your orientation cube. So if you want to look straight down of it at it, you press the up, or this is looking from south. So that is your orientation cube. And on the left-hand side is where all your tools are, and all the menus for tools and materials, and that's how you visualize the point cloud. Up at the top here is a hyperlink. This allows you to go back to LiDAR Mill. If you click on the project title here, it'll open up the project page within LiDAR Mill. And at the bottom right is the help menu, and that's where you'll find this video is in the help menu, as well as some other tips and tricks for the tools that we use. Okay, so this project is called the Fish Canyon project, in which we used a Ranger, and you'll see a stream and a bridge here. So typically, depending on the graphics card that you use, I'll increase the number of points, our point budget here. You have the option of using measurement of creating measurements in feet or in meters. And with some web browsers, you may have some issues with displaying points, and one option of remedying that issue is by deselecting the iDome lighting. So the iDome lighting gives you some more depth in the point cloud, as you can see here. So if you are having an issue displaying points, then deselect that iDome lighting. You have the option of the different backgrounds. So this is called a skybox. So you could see the sky, you could see a gradient, black, white, and soon you will be seeing an option that is called map. So the map option will allow you to see a cesium map in the background of where this project is located. So that'll be the last one here, and it'll say map. But for now, typically I leave it on gradient or black. So next you have your tools menu, you have your scene menu, you have your materials menu, and your classification. So often when I will open up a point cloud, I will basically get rid of a lot of the noise. And I think you could see these blue points down here. If you can't, then let me increase the point size. And now you can see we've got a lot of low point noise. So what I will do is typically first step is to remove those low points that we've already filtered out, and zoom in onto some features that we're looking for. To zoom in, you can use your mouse wheel, you can use your mouse, but typically if there's an area of interest that I want to zoom in on, I double click. So if in the case of this bridge, you hover your mouse over the bridge and then double click on a point, and then you'll notice the cloud viewer will zoom in on that area. You can also notice that over time it's loading more and more points, and these are tiles that are relative to this bridge, this location. So over time you'll see it get more and more dense, or higher density. So yeah, so to zoom in, you could use your mouse wheel. Left click allows you to orbit, and a right click allows you to pan up and down, left and right. Okay, so a quick overview of the tools and what I'll often use in the viewer is one of the most useful tools that I use is basically your 2D profile. It allows you to assess how well your separate flight lines are matching up. And typically right away you'll know if your flight lines are matching up based on classification. So if I want to assess separate flight lines, typically I'll go into the materials attribute, and you'll see several attributes here which you can individually select, but I find the most useful one is the composite attribute. The composite attribute allows you to visualize almost all of the attributes that we have here and assess the one that's most useful. So you can also assign them weights. So on the left hand side we have RGB, elevation, classification. So I can basically assess elevation as well as classification, source ID, amplitude, intensity, several weights all at the same time to narrow in on what could be optimized or how well a certain feature is working. So for instance, if we want to look at first classification, you could see that those orangish points are ground, and so that this is a dam here, and we would know that that concrete dam is ground. So overall this classification is quite good on this project. So if we remove the unclassified or the non-ground points, we now can see that these are all of our ground points, and these are our unclassified points, and the never classified is your trajectory. So typically when I'm drawing a profile, what I will do is look at source ID. LiDAR mill basically auto detects flight lines. So we can see our straight flight lines here, and it also detects curves or turns. And in the scene here you'll find all of your flight lines, but you'll also see a curves option. And I will first thing typically remove the curves because any sort of turns or curves in your point cloud will add error to that to the project. So first thing is first, I'll typically remove the curves from here to analyze just the straight accurate flight lines. And you also have the button here for the trajectory. You could also hide the trajectory. So let's say we want to look at the dam here, and we want to draw that profile. So we can draw the profile across here, and at the bottom, every time you make a measurement, you're going to see these measurements pop up here. So under the measurements, you can select those individual measurements, and it gives you additional options which you can modify. So right here it gives you the width of that profile that I just drew on the dam. So let's say I want to make that 5 meters. So now that is 5 meters across. So there's two useful features in what I do when assessing a profile. Is first is, of course, you can generate that 2D profile, and now this 2D profile is now looking in from the side of that profile. But you can also look in, so now we have a 2D view, but we can also look at the 3D viewer. And you have this nice menu here. It's called a clip task. And in clipping, we can highlight or visualize just what's inside. So when you clip inside, now we have a 3D view and a 2D view down below. So what we can see is that all of these flight lines match up quite well. And this is a 5 meter section. If you want to truly, analyze accuracy, you'll want to take a 10 centimeter cross section. But we're just assessing how well these flight lines match, and we could tell the orange, all of these flight lines match quite well. If you want to identify which one's the issue, the weights is how we're visualizing. So right now we're visualizing by point source ID. Down below you have the ranges, and what this allows you to do is to quickly sort and hide certain attributes. So we know that we've got, if we look up above, 1, 2, 3, 4, 5, 6 flight lines that we're visualizing, and the rest of the points are curves. And let's say we want to identify a flight line that may be causing additional error. You can quickly do that by adjusting your point source ID. And down below it says that I'm visualizing 0 through 4, or I can visualize 3 through 5. And this is a nifty way of identifying, which flight line is causing any sort of matching issues. It also allows you to identify if the sensor's field of view is adding more error as well. A lot of users out there are using the full scan angle or the full field of view of the sensor, and as you do that, if you use a 140-degree field of view, it may add more error. So what I find is very useful is to limit the scan angle to, say, -50 and +50. So that's a 100-degree field of view. And you can see that if I just go back to highlight and I zoom out, and you could see the orange, the purple flight lines here. And you go down to scan angle. I'm going to start on the right hand side. So that's 50. So that's +50. And let's go to -50. So we got rid of a lot of that, which could potentially be noise. And let's go back to our clip task inside. Yeah, you could see that it did. I still looking at the full range. So it did clip out a lot of those, a lot of different overlapping flights with that scan angle. So basically, this just allows you to adjust these to find the optimal settings, the optimal accuracy settings for this project. So that is scan angle here. We can view also by intensity. So let's go back to highlight, and down below we're going to view by intensity. Let's bring our point size back down. I'm going to close the 2D view for now. So now we're looking at a combination. So intensity is a combination of reflectance and amplitude. You have the option of also looking at just the sensor's amplitude, the sensor's reflectance, and the deviation. So deviation is the longer that pulse width, um, the basically the color difference here is that and let's go sort by deviation. So these are higher pulse widths, and you'll typically see this with vegetation, and the blue is the shorter pulse widths. So inside vegetations, you may have a longer or higher deviation, or a larger pulse width. But it's nice to visualize that as well. So typically, I'll visualize by a combination, let's say, an intensity and elevation. Um, you can also visualize intensity, elevation, and point source ID. There's a lot of custom options here you can visualize. What's also interesting is sorting by GPS time. Now you have that ability, and what I like to do is add the trajectory into the mix as well. Is you get to sort by when they were acquiring the data, what was their flight path, how can they optimize the flight. This is how you provide feedback to the pilot and the team acquiring the data. So it looks like they called it short here and headed back. So that's GPS time. Another fun item to visualize is the return number. So if you have a lot of vegetation and you want to assess how many returns you received, there's a return number attribute weight as well as the filtering. So we can look at the red are the first returns, the green are your second, and then we have a third blue return here. And this assesses how deep into the project you get with returns. So that's basically an overview of the materials. You can look at single attributes. So you can isolate just elevation. You can look just at GPS time. But I typically like to go straight into composite mode and to sort those attributes on what I'm analyzing or assessing. All right, and for a lot of the systems like our Ranger or mini Rangers, you may get quite a bit of noise right around the sensor. When you do that, you can always adjust your amplitude, and that significantly helps with the amount of noise that you're seeing directly around the sensor or below ground. So adjust your reflectance to what you think is right, and then you can make a note of that when further post-processing the point cloud. Okay, so back into our tools. So you've got your angle measurement, you have your point measurement tools, you have your distance measurement. I find this height measurement tool very useful. So if I want to draw another, let's say I want to assess how high really the UAV was from the point cloud, I can draw another profile. Let's look at this from source ID. Actually, let's just look at it from elevation standpoint and a little bit of intensity. And let's look inside that 2D view. And I'm going to double click right in our profile. Let's look inside. And I'm going to change the elevation so we can see our trajectory. And let's see here. And then let's go highlight inside. There's our trajectory. So it was a little bit hard for me to see earlier, but you can see our trajectory that falls inside of that profile. And here's our other profile in the background. Just a handy tool. If you do not want to see the profile in the background, you can always, if you want to delete all measurements, you can select this big red X, and that's remove all measurements, or you can remove individual measurements by this small little red X. So when you select the individual measurement, at the bottom right, you'll see this. And if we want to remove that measurement in the back, you just click that X. All right, so we could see the trajectories here. There's 1, 2, and 3. Let's measure from this one to ground. You could select this height measurement tool. You select that and find some point on the ground here. And basically that measures straight up and down. So it's useful for power lines. It's used for buildings, for many certain features. Because if you try to use the standard distance measure tool in 3D, it's very hard to get that correct. So with this height measuring tool in 3D mode, it's a lot easier to get an accurate height measurement. And in this case, we are flying 48, about 50 meters above ground. And I believe you can switch those measurements to feet, of course, feet or meters. Another useful tool or camera projection I often use is ortho mode or graphic projection. This allows me to get a cleaner view or profile to assess, the accuracy of that point cloud. So that's it's ortho, and then you have perspective as well. If something happens like that and you do get lost, you can always click this full extent, and now that brings you back to the full extent or the up side of the orientation cube. And let's go back to highlight. So another useful tool you may find handy when, let's say, if you want to focus just on this bridge for certain, visualize that bridge for certain things, is it's called the volume clip, and you can set that in the point cloud. You have a whole bunch of these orientation options. So if I want to, let's say, rotate the cube, and let's extend it down here to the left. And let's bring a little bit higher. So what this does is that it will clip. If you select inside, it will clip, a lot of things that well, you want to visualize. So it's quite handy in case of buildings. Um, let's move this up a little bit. Let's delete this profile and that height measurement. Let's go into ortho mode. And we want to double click on an area, so that's the area that we orbit around. Click inside. Now, depending on your internet connection, it may take a while to load some of these points. This one has a very high point density, but you can see on this bridge the individual I-beams. You can see a lot of the detail from this project. So that is the clip task. They also have these orientation, these view tabs. So if you want to view from the side, or let's say from this side, now we're looking at the end. A lot of handy options for visualization. So that is, and now let's go back to highlight. So that is the clipping. You can also, instead of the box, you can also run a polygon around the area to clip. So you left click, and once you're done, you right click. Make sure you right click when you're done, and then you can select inside again to view just that area that you selected with a polygon. Okay, so let's delete that. And these are the same as your orientation cube. These are different flight modes. You've got your orbit, helicopter, or fly control if you want to do any screen recording. Um, let's see here. The other useful tool that I do want to mention in 2D view, so let's bring our profile back up. So profile, just as an FYI, you can draw as many profiles as you want. Once you're done with the profile, make sure you right click, and that ends the profile. What I typically, and don't forget, when you're drawing a profile, go back into highlight mode, not an inside, or you won't be able to see that profile. So left click, go to the end, click left click again, and then immediately after right click, and now the clip, the profile is done. Then we go down to our profile, click that. You can see, let's make that 5 meters. And every time you increase the width, you could see the red band grow. So let's just say we want a 5-meter profile. And let's go into view just the inside. So I want to compare, so we're in ortho mode. And let's look at our 2D down below. And let's say I'm just going to look at elevation for now. In the 2D profile, you can assess height and accuracy by the numbers on the left, or you can use this protractor we have here on the top left, and that gives you a triangle which gives you length, height, your hypotenuse. So let's say here, so we select on a, you got to select on a point. So length, height, your hypotenuse, and also your slope in degrees. So that's very handy when you're making certain measurements to ground or from flight line to flight line. Um, it's really handy to really narrow into the accuracy of the point cloud. Once you're done with that measurement, you can click the X or the delete, and you can turn off that protractor here. Also on the left, you have this guide that tells you, so let's turn off the protractor, that tells you for each individual point, the amplitude, the deviation. It gives you some insight into these points. Where that's helpful is if you're trying to, if you've found some noise in a certain area, you can look into here into that point and find out, okay, that one had a amplitude of 1636 or very high deviation, and that helps you isolate those noise points. So that's what we have here, in addition to your XYZ, your color intensity, and your scan angle as well. So this one has a scan angle rank of 74, so that's quite high. So this is a good overview, I think, of the tools and really the options you have with this cloud viewer, the Phoenix Cloud Viewer online. If you do have any questions, you could always email us at support@phoenixlidar.com, or you could check out our forum that has a lot of insights on tools as well as other LiDAR mill tools. Thank you for watching.